The first couple, the first three actually, asked you to test. Test the claim to see if it approximates a normal curve. Now the problem is, if it doesn't approximate a normal curve, you have to stop. You can't do this. The product of both of those, n times p and n times q, have to be greater than or equal to 5. Way back, we saw like 4 sets of graphs, and they showed us when it wasn't greater than 5, it was a skewed curve. So once they hit the 5 and they get higher even, it becomes more and more of a normal curve. So the first one doesn't pass the test. If you just test the smaller of the two probabilities, whether P or Q, and it passes, then the larger one has to pass. In 6, it passed the test, so they wanted you then to go ahead and do whichever way you wanted to do it. A cutoff or a p-val, whichever way you wanted. If you use your calculator, that's better, that's easier. If not, they gave you your test information versus your population information. Plug it in and locate this. Now, a couple of you are asking, my cutoff is way up here. It's a right-hand test, but my z-score is completely on the opposite side. What did I do wrong? Nothing. You take your test minus your population. 0.64 minus 0.7 is going to give you a negative z-score. Now, as a person who challenged this claim, I might look at my sample, and I might say, well, I sampled 225 people. Did I get a really good representation of my population? Would this be a normal thing? Was his claim or the researcher's claim that far off that I know I'm challenging this? That's what you decide. Sometimes your samples are not a good representation. I could sample 24 of you. I could take 5 people and actually get the top 5 scores, actually get the bottom 5 scores, actually get the middle 5 scores. That would happen. It doesn't have to be 1 from the top, 1 from the bottom, 2 from the middle. It doesn't have to be as random as you wanted it to be. So you have to make that decision. Should I do another sample? Is my unusual sample good? I should count this sample. Yes.
For number 6, would you be able to do that in one property z-test?
Yes. Do it in your...
How would you put it in? For like the x, finding the x.
So let's go put it in. Oh, for your S, you first have to take this your p hat, and multiply it by how many in your sample.
Okay.
Because it's a proportion based on your number in your sample. So what did that multiply to?
I did the formula, but I wanted to...
Okay. Can somebody do 0.64 of how many people? 225? You just can't put a decimal. 141?
144.
144. Thank you. If you get a decimal, you can't use a decimal. And follow your tail. And watch, it gives you your p-hat back, so you can test your p-hat to make sure you did it right.
So what would our z-score be when you put it in?
Your z-score comes out to be negative 1.96.
No, when you put it in the test, you don't need it?
No, you're putting in x, one proportion z-test, you're only putting in an x and an n, and your population. Remember, it doesn't know your population until you tell it that.
And you have to put the claim always.
You put your population, that's from your claim. Number 8, you couldn't do number 8. Number 9, did a reject region. I'm not sure if God bless you what you said to do, so I did reject. God bless you. Check your answers, guys. Mary?
God bless you once again.
Yeah.
Oh, wow.
Your cutoff, your inverse norm, did you do inverse norm 0.05? Okay, inverse norm 0.05. You only divide by 2 if you have 2 tails.
God bless
God bless you.
you. God bless you.
One tail, you just put inverse norm 0.05, which is the opposite of your confidence interval. Okay? Find it and then give me your interpretation. Your claim was your HA, so you're going to use the word support. If your claim is your HO, you're going to use the word reject. Make sure you even spell that claim out to me. And some of you are having problems with this. If I say 20%, how do I turn that into a decimal? So the rule is, move the decimal place. if I have 19.3%, what's my rule? Move the decimal place. 0.193. If I need to know my x, it's 9.193 times 200. And you cannot put a decimal in. Did this come out to be 39? Was this the one?
No, it's not.
Yeah, 39. It was 38.6. You cannot put a decimal. It can't be a partial person.
Why did you
If you use your calculated steps, you need an x. If you use your formula, you got the p hat. You're fine. You will have a problem with the when they give you an x and an n. Then you have to take the ratio and find the p hat.
That's what I
Right. So in one time, the calculator says, make sure you give me the x, and the other time, make sure you have the p hat. How do I say 5% as a decimal?
0.05.
0.05. Good. How do I say 95% as a decimal?
Yeah.
0.95. So if I want to find 5% of n, I multiply 0.05 times n. I shouldn't have to be going over that with my college level students. Okay. A research claims that at least, think money in your pocket, you have at least $5. You have that or more, greater than or equal to. That's your claim. So your text, therefore, is its complement. It's the less than 0.46. If you put a proportion in without your decimal in your calculator, it will not work. Because you just said 4,600, or you said 100 on that. So make sure you move that decimal from 46% to 0.46. Use your calculator, find your reject region, make sure you label. Questions? Are you kind of getting
Where you get the 2.6?
from the x value? Because if you use your calculator, you got to take 41% of 600. If you use your equation, 0.41 is your p hat. But if you go to use your calculator, it wants the x value. 41% of 600 is your x. Your p hat is this. Look. X over n. So this is the problem. If they give you your p hat and you want your x, you're going to cross multiply. P hat times n equals x. So if my p hat is 0.41 times my n, this will give me my x. Okay, next one, number 12. This is an equal to. Claims that 5%. Not less than, not more than, that. That's my equal to. 0.05. Make sure you don't put 0.5. That's 50%. So 18 years of age, it doesn't matter. 9.6%. How do I turn this into a decimal? Two places, 0.096. So if I need my n and my x, I got to multiply 0.096 times 250 if you use your calculator. You got a two-tailed test. Make sure you take your 0.05 and split it in half for your cutoff value. If you like your p-val, use your p-val test. How are we doing with this?
I thought I got it wrong.
You got it right?
Yeah.
Now, you thought it was wrong because this was so high?
Yeah.
It's possible. It's just possible. You're way off here. So that's when you look into your thing. Did you maybe not challenge him when you shouldn't have? Did you maybe read your sample not what you thought it would be? You know, maybe the researcher was on the nose when he said this and you didn't think so. That's when you look into this a little bit more. You could get a z-score of 100 if that was the case.
So the only thing you do is say yes.
Okay. Claims that this is less than is the claim. So therefore you're going to use the word support when you give your final answer on this. This gave you an X and an N. So this is Demani's case when he uses the p hat.
I had to divide.
You have to divide it. If you use your calculator, notice your calculator does return you the p hat. Aaron? The calculator returns you your p hat if you use it. This is
No, you divide the number, the sample number. The X over N.
okay. Listen, out of 400 people, okay, out of 200 people, 100 people said yes. What percentage said yes? Okay, out of 200 people, 100 people said yes. Oh, so how did you get that? Oh, you divided. 100 divided by 100 divided by 200. It was a half, right? 50%. Same thing. 156 divided by 400. Okay? Guys, the last one. Now, they wrote it backwards. They gave you your sample information first. Well, they just tried to fool you, but I'm sure you read it more carefully, and you said, guys, give me 1 minute. In a random sample of 50 adults, here comes my sample information. The results of that survey, that was from your sample. This is your p-hat. This is your p-hat, 48%. Then the claim is the 52%. That's your p. They just set it up backwards. They're allowed to do that. And then are you more likely to buy at least, so there's your greater than or equal to, there's your less than, there's your q. Your q happened to be the same as your p-hat.
Yeah, that confused me at first.
Yeah. Yeah, when I did this too, I said, well, I wonder if they did that on purpose. That your q came out to be the same as your p-hat. Set up your formula, set up your calculator, and find your answer.
Wait, so it doesn't matter if you multiply by the p-hat or the p